Next, let's look at a couple of discrete probability distributions. So binomial distribution and Poisson distribution. So binomial, we've already seen binomial, right? So it's a discrete distribution, so it has to be either 0, 1, 2, 3, and so on up to n. And the two parameters are number of trials and probability of success. So say for example, if you have 10 trials and the probability of success is 0.2, right? So then in Excel, you have a nice inverse binomial probability function is available. So it's really very easy. So you generate a probability, okay, rand, and then simply use binomial. So binom.inv. So first is trials. So that's number of trials, right? And then probability of success, that is trials probability of success is the second item, and then the rand value. So this will give us the inverse binomial. So what x will be a number between 0 and 10 from the binomial distribution. So if you just press the delete key, you'll see the x value changes, and it will be according to the binomial distribution. Now, unfortunately, for Poisson distribution, we do not have a Poisson inverse function. So you have to really set up an inverse lookup table using binomial Poisson distribution. So for example, if you want to generate Poisson random variables for a process, okay, and also Poisson is an infinite discrete, but without a bound on the right side. So whole number, any whole number starting from 0, and suppose we want to generate Poisson random numbers that has an average of, say, so here 5 arrivals in an hour, for example. Okay, so and you want to generate how many arrivals you will have in each 5 hours, okay, or each hour. Okay, you can always, if you have a smaller time interval, you can always change the lambda value to whatever time interval that you're interested in. If you're interested in 5 minutes, then change it to what is the lambda for 5 minutes, and then set it up. Okay, and here the possible values, I'm going to put the x value on the right side because the lookup value is cumulative probability, so which will come from your rand function. So that gives us the probability. So what is the x corresponding to that probability from Poisson distribution? So we're going to have to set up the values. So if it is 0, okay, then 1, 2, okay, well, 3. You have to make sure that you go far enough. You don't have to go all the way to infinity. Obviously, you can't do that. Now remember the lookup table in VLOOKUP, we're going to be using VLOOKUP. So the lookup value should be the lower limit of the probability corresponding to each of those x's. So the first lower limit, of course, is 0. 0 is the first lower limit. Okay, and then we have to have cumulative Poisson distribution probability for each of them. So you have Poisson table distribution, right? So x is from here and mean is from here. Okay, press F4, and we want cumulative probability. Okay, so now we have the lookup table. Okay, so these are not actually 1, because if you increase the decimal places, you will see that getting close to 1. So now you use the VLOOKUP of the lookup value is the probability, and this is our lookup table. Okay, and the second column is where the X is going to come from. So it's a little more involved than binomial. Binomial, fortunately, Excel gives you an inverse binomial function, but we don't have inverse Poisson function, so we have to set up the lookup table and then use it to get the random numbers.